Okay, this is where we were when we left off. We did these first three. Then I did go through this one with you in class, but let's look at it again. Okay, we got everything on the one side. It says put the equation in this form. Okay, once you put it in this form, now there isn't always a number to factor out, like we said, but in this case there was. I took a 2 out. Then I'm just looking at this for my A, B, and C. A is the number in front of x squared, that's 1. B is the number in front of x, that's -7. C is 9. Okay, we factor the 2 out. We're going to find the discriminant, which is b squared minus 4ac, so we know whether or not this could factor. When I take b squared, -7 squared is 49. Minus 4 times a times c, that's 49 minus 36. That gives me a 13. Is 13 a perfect square? Is 13 0? No. That's the only time we take the time to factor, like we did with number 1 when this was a perfect square. The discriminant, when I took the square root of 361, I got 19. It was a perfect square, so we factored it. Here, it was 0. When I found the discriminant, b squared minus 4ac, it was 0. So we factored it. And we knew there was just going to be one answer. The parabola just touches the x-axis at 2.5 or 5/2. When I did this one, I found that the discriminant was -47. If the discriminant is not a perfect square, or if the discriminant is negative, then you use the quadratic formula, which we did. There's no real answer here. They're imaginary. -5 plus or minus I squared to 47 over 6. Now we're on to this fourth one, and I got a positive number, not negative like here, but it's not a perfect square. There's no number times itself gives me 13. Okay, so I'm going to, again, use the quadratic formula. Okay, x equals the opposite of b. B was -7, so the opposite of b would be 7, plus or minus the square root of b squared minus 4ac, which we just figured out was 13, all over 2a. 2 times 1 is 2. Sorry, that got involved there. So my two answers are 7 plus square root of 13 over 2 and 7 minus square root of 13 over 2. Those are my two answers. If I look at that on my calculator, if I go ahead with your calculator, take 7 plus the square root of 13 and divide it by 2, you get about 5.3. Then if I do 7 minus the square root of 13 on my calculator and divide that by 2, I get about 1.7. So that's where I'm going to be going through the x-axis here. About 5.3 and 1.7. If you do that on Desmos, you'll see the answers. If you graph y equals x squared minus 7x plus 9, that's what you'll get. Okay? All right, I did want to do this last one. I know I did it with you in class, but this is a little odd in that when I try to get this equal to 0, which I can do, I subtract x over there, there isn't a c term, right? I just have an ax squared plus bx. There's no c term. You still can do the quadratic formula, but I would suggest just factoring the x out. This is what we did. This was the first thing we did in this unit. Okay, so you have x times 3x minus 1. Set each equal to 0. X is either equal to 0 or 3x minus 1 is 0. Let's move this over a little bit. Sorry, I was having trouble looking at that. Okay, so for 3x minus 1 to equal 0, I would have to add 1 and divide by 3. That gives me x equals 1/3. So this is really hard to see. That's why I did a different graph. Let's say there's 1 and -1. I'm crossing the x-axis at 0 and 1/3. This is a tiny little parabola, isn't it? Okay. So there's your graphic organizer kind of filled in for you. I know we did these differently in classes. I want you to watch this video, but realize we're going to re-emphasize all this in class. I already did on Monday, and we will again on Thursday. Okay, now the other part of the bottom half of this graphic organizer, I want to kind of go through the square root method with you. We mostly use the square root method if there's only one x term. Like here we just have x squared. Here we just have x. Here we just have x. Here we just have x. Here we just have x squared. Okay? That's when we if there's only one x term, you're either going to use the square root method or sometimes it's the difference of two squares. So for example, for this one, I might just use the square root method. 6x squared equals 12. Divide by 6. X squared equals 2. So x is plus or minus the square root of 2. Okay? On my calculator, I figure out what the square root of 2 is. It's about 1.4. So I'm going through at 1.4 and negative 1.4. Okay, if I would graph y equals 6x squared minus 12, that's what I would see. It goes down way further, actually. I'm not giving you an accurate look here. 0 is negative 12, so that's more like this, okay? This one, again, I'm going to try to isolate the x minus 1 squared. So I have 2 times x minus 1 squared equals 8. I'm using the square root method, which is get x squared by itself and then take the square root of each side. I'll divide by 2. That gives me x minus 1 squared equals 4. And now I'll take the square root of both sides. X minus 1 equals plus or minus the square root of 4. So x minus 1 equals plus or minus 2. So x equals 1 plus or minus 2. Well, 1 plus 2 is 3. 1 minus 2 is negative 1. So if I would be graphing this equation, it would be going through the x-axis at 3 and negative 1. I would use Desmos to double check it. Looks like the vertex is 1, negative 8. And, sorry, imagine that that's a little neater. Okay? This one, here, let's just graph it quick. What is it? Y equals 2 times x minus 1 squared minus 8. Okay, so let me just do that for you here. Let's go to Desmos. Okay, what we're saying is if I graph, move this over for you. Y equals 2 times x minus 1 squared minus 8. Look where it's going through. 3 and negative 1. Okay? Just want to make sure to verify that. That's what I mean by use Desmos and double check your answer. Okay? I hope that makes sense. 3 and negative 1 is what I got. In this case, it's not quite as clean, is it? I add 10 to the other side. Divide by 2. Now when I take the square root, I get x minus 1 equals plus or minus the square root of 5. I can't take the square root of 5 like I could take the square root of 4. Yuck. So I have two answers. I'm going to add 1 to the other side, just like I added 1 here. But in this case, I was saying, 1 plus 2 and 1 minus 2. Now I'm saying 1 plus the square root of 5, 1 minus the square root of 5. So my two answers, I'm going to have to get on the calculator. Okay? Okay, so it's 1 plus the square root of 5, just to give me an idea where it is. It's an irrational number, about, I'm just going to say 3.2. So about 3.2, and also about, okay, that was 1 plus the square root of 5. I also want to do 1 minus the square root of 5. And that is about negative 1.2. Okay, so in other words, if I would graph this on Desmos, y equals 2 times x minus 1 squared minus 10. If I would do that on Desmos, all I'm doing is changing this to a 10, right? Now it's at, 3.2 and negative 1.2. Okay, that's what I'm finding when I do this. Okay, so I'll just sketch that. What was it? Oh, 3.2-ish, negative 1.2. That's what that would look like. Okay, here, we have a negative. So I have x minus 1 squared equals negative 2. When I take the square root of that, I get x minus 1 equals plus or minus square root of negative 2. I'm going to add 1 just like I did over here, but square root of a negative is imaginary. Here are my two answers. I'm not putting that in my calculator and getting a decimal approximation. It's not a real number. Okay? When it's not a real number, what's that mean? Let me see. Let's graph it. What was it? 2 times x minus 1 squared plus 4. 2 times x minus 1 squared plus 4. Oh, it's a parabola that never actually crosses the x-axis. Now that makes sense. That's what an imaginary number is. Look where the vertex is. Think back to graphing. The vertex is at 1, 4. It opens up. Where's this going to cross the x-axis? Never. It has two imaginary answers, not two real answers. This one, I just wanted to show you. If you recognize that you can take a 3 out, okay, this is 3x squared minus 75 still, but x squared minus 25, I haven't done much lately with the difference of two squares. And I would want to show you that this one does factor. I get x equals 5 or x equals negative 5. Okay, if I would graph that, 5 and negative 5. Okay. Here's negative 5, there's 5. I'm not going to be able to see where this goes, but okay, but it's a parabola that goes through 5 and negative 5. If you wouldn't have solved it that way, you probably would have said 3x squared equals 75. Divide by 3. Take the square root, plus or minus the square root of 25. You get plus or minus 5. Okay, so it's not a big deal if you don't notice that you factor that into the difference of two squares. Either way, you get 5 and negative 5. Okay, so now your task is to do the back. Oh, I'm upside down. Do the back of this. Okay, solve all these equations. I'm going to post the key. I also want you to do the error analysis, and I'll post the key. And this video, plus you doing that and checking your work, serves as your review for the test next week. Okay? All right, good luck. See you at my office hour Wednesday if you want to come.